Today we're gonna be doing something fun and building a cool utility you can use to create powerful command line interfaces. We'll be building a command line processing framework that can work either in one-shot or REPL mode. And in commemoration of the launch of C# 11, we'll be leveraging the .NET platform to do this. But before we get started, let's talk a little bit about the functionality we want to create. Now, we've all built console applications to accomplish odds and ends in the environments we work in. The .NET command line tooling itself is a console-based application with multiple parameters that can be used to create a myriad of .NET projects. So we should all be comfortable with the rules of engagement and the constraints we must deal with regarding them. For instance, in a C#, all console applications receive their arguments through an array that's passed in when the application starts. That's the args right there. Now, when complex commands are being passed in and need to be represented in this string format, but they contain command line switches and parameters, they contain spaces, it can be somewhat difficult to properly parse the array to pull those arguments out. It's not impossible, but in the grand scheme of things, the question you should ask is, how much time is one really willing to dedicate to doing this, particularly when this kind of brute force parsing will likely need to be repeated with each situation we encounter. Now, we looked through several frameworks over years and found them all to be lacking in one form or another, primarily suffering from simply being too robust for this kind of hit the ground running organic approach we're looking for. So like the organization that fixed up Lee Mages, we decided to build a better one, stronger, faster, you know the rest. That being said, the proverbial $6 million question is, how do we do it? What usage pattern and approach do we think is the easiest to use, yet powerful enough to support usage scenarios as robust as the .NET tooling itself? For this, we drew inspiration from the Web API family of products, given that the mechanisms they employ have been very successful in building powerful RESTful APIs, are easy to use and straightforward to understand, and happen to already be very popular, so don't really require much in terms of a learning curve. The Web API pattern, like the approach used in products like Azure Functions, as an example, utilize attributes to decorate methods in a class as a means of identifying them as participating in the framework. These simply take a string representation of the URI used to invoke them. When you need variability, like when you need to pass parameters into that string representation, it can be introduced into the URI string by inserting placeholders encased in brackets. That way, when the URI is requested, the actual values of those placeholders is passed into the very method identified by the route through the parameters of that method. Now, as long as the route pattern matches the URI requested and the parameters of the method match the placeholders found in the request, the method is invoked. And this is, of course, a simplification, but you get the picture. Now, our console processing framework will leverage this approach as well. All users need to do is apply the attribute we designate to any static method they want, like Web APIs. And when a given input string is passed into the console via command line or REPL, the associated method will be invoked. And like Web API, we will also use embedded placeholders in the quote-unquote routes to introduce that variability that you see there. The advantage of this approach is in the speed with which one can get started and the ease with which capabilities can be enhanced. Like Azure Functions and Web APIs, anytime a new capability is required, all we need to do is create a new static method, add the functionality to it, and decorate it with an appropriate pattern that must be matched for the function to be called. There's no scaffolding, none, other than the attribute and pattern you want to use. Now that we've described the problem statement, let's get started by building this cool new tool. So let's go ahead and get started. As stated, we're going to be using console application. This is really a test application. So we'll create our solution. Let's new solution, we'll call it the Pigeon framework. Okay. And in here, we'll create something we'll just call our test harness. And this gets us going. And then we'll also need a class library that will actually be the framework itself, right? That's actually going to be the thing that we're working on. So class library. And there we have it. And then we're going to go ahead and let's get rid of this guy because we're not going to need it. And we should now be at a point where we have the framework that's going to be testing and the test harness that's going to be testing and the framework that's going to be tested. And let's add a project reference so that it's referencing it. And then let's run a build and make sure everything works. Perfect. Now that the projects are created, let's go ahead and start by creating our actual attribute. This is the attribute that we're going to use to decorate all the various functions that we want to essentially serve as the processors for command line input that matches in one form or another. So we'll create a new class and we will call it command. And we'll call it console command. Okay. And this is actually going to be a console command attribute because these are actual attributes. Yes. Okay. And since it's an attribute, we're going to inherit from attribute itself. Right. And our attributes, we want only to work on methods. So we will target it to methods. And we can allow multiple. That will basically mean you can add multiple attributes to the same method. For whatever reason, the same function might work coming from different places. It's a way for you to mask the commands to a certain extent, but we wouldn't do that right now. This, of course, needs to be public, since this is the public framework that we're creating. And we obviously need to add the constructor, right? And the constructor would obviously take a pattern, right? So there we go. We have our attribute now, start out. We're gonna come back to it, but let's first of all go in and let's create a method, one of our test methods. So static. Okay. And then over here, we'll add our attributes. So console command. And return true. And in here, maybe we want to say something. So say something. And then in here, this is our basic setup. Don't have to do much, but this is kind of how it would work for now. This indicates that this method needs to be called, and then the fact that that method needs to be called now, then yada yada yada. The hijinks continue. So let's go back to our attribute and let's see what else we can do. So we're not just going to need this, right? So if you look at this, you might imagine that, okay, well, what if I typed in goggly gook, right? What if I typed in you know, some crazy stuff. I didn't type in exactly the word say something. What do we want to happen, right? Well, we also probably want another attribute there. And I'm going to do this a different way to kind of show you a cool way that you can do some prototyping. And then if you like it, switch it over to a class with the refactoring capabilities of Visual Studio. So I'll just create another one. Actually, I'm just going to call it command not found. This would also be the same thing, another attribute. And essentially, actually, I'm just going to copy this from here. Essentially, it's the same thing. The only difference being that we obviously don't need a constructor there. So now that we have this class created, we can just do a quick refactoring, and then we say we want to move it to its own type, and that gets moved away, and now it should show over here to the right. Okay. So we can now go back here, and we can also add another class. And then we're going to decorate this with the command not found attribute. And we will return false. So why am I using true and false here? Well, remember that we want this to work not just as a one-shot console application, but also as a REPL within a REPL loop. So when this works within a REPL loop, you would want for at the end of any command, you want to know whether or not you should continue running the command or not. So in this case, whenever this command is invoked to say something, it just continues. And whenever nothing is found, it ultimately stops, right? After it gives some information. Right. So there you have it. So now what we want to do is we want to create some of the classes that are going to be used within this command attribute to essentially assist it in identifying the various pieces of a string. So for example, you've got a string like this, say something. Of course, this something, based on the way we want to do it, should look something like that, right? And then there should be a string here that's called something. So these two match, right? And then in here, we would then change this to say, you said, this here. And then we can enter our placeholder, something, right? So we want something like this. So obviously in a string like this, we're going to have to do some parsing to identify what, that this part is the placeholder and this part is just regular text. So we have to create something to control that. So we're going to follow the same pattern and create it here and then basically build it out. And what we need is something that I think we can think of as a span of some kind that represents a piece of text with basically an index within the string and how long it is or whatnot. We're not going to get to that level of detail for this exercise, but we can create a very simple one here. So public, I'll make it a record. And for sure, we want the span to have the actual text. And then the only other thing that we want is we want to know whether or not the text is a placeholder or not. And the reason why we're getting these green squigglies is because by default, these SDK projects now essentially, make nullability, nullable reference types a default. Easiest way to fix that is just to open this and disable that, right? You can close that, and once you do that and it refreshes, it'll be gone, as you can see. So we've got our span now. And the next thing we want to do is we want to go back to this attribute, and we actually want to store the span in the attribute. We could create another type for this, but I'm just going to, for the purpose of brevity and to simplify the framework, and really because it honestly doesn't matter that much where you put it, I'm just going to do it here. So we'll call it tokens. And we always want there to be some token. So we'll create that. Now we also have this pattern string that's here, and we probably want people to be able to access this. We might want to access it at some point in the future. I want to know what the pattern that was defined here. So in this case, this string, say something, what it is. So this represents that. Okay, and then we just want to pull it in from this pattern field here. So pattern equals pattern. And then what's the next thing we want? So next, within the actual command attribute, we also want to store a reference to the method, right, that it actually is associated with, right? So that can be tracked as well. So let's go ahead and let's do that. No public. And this we can leave undefined because we don't, it doesn't matter to us at all right now. I mean, it's always going to start out without us knowing, right? It's going to be something that happens for us to figure out what that is, and we'll talk about that a little bit later. But then finally, we need to somehow, I mean, there's a bunch of ways to do this, but the easiest way to be able to determine, because ultimately we're going to have to loop through all the various, whenever you enter some text, and let's say I enter text, say there, buddy, right, or whatever. I need to be able to match that text to this particular pattern that's here. So we need some kind of way to convert this into a regular expression that we can use to easily match it. So why don't we do that here? So, and I'll make it a property so that it can be used more naturally. So here's the regex for the pattern. We don't need a setter, we only need a getter. And of course, we're creating a regex based on the pattern. So let's create a regex builder equals new string builder. Okay, so we have our string builder. And now that we have our string builder, what do we need to do? We need to iterate through the tokens. And then for each token, we need to create a regex that represents finding that token, right? So right. So what are the two kinds of things that can be in the token? Well, we already showed it before. It can either be a placeholder or it cannot be a placeholder, right? So if it's a placeholder, we'll do one thing. And if it's not a placeholder, we will do another, right? So if it's not a placeholder, then we just want to put it into a class, right? So we just do this. So we just put it into a normal class. This is a regex class, I'm saying, token.text. So this will match that entire word together, whatever you have in there. And then up here, we also want to match it, but we honestly don't know what it's going to be, right? It could be anything, any combination of any number of letters, text, space, whatever it is, doesn't matter, right? So we've got to build a regex for that. So we'll do the same thing. Append it. And then in here, we need that, sorry. we're going to be, actually, let me do this. In here, what are we going to be doing? Well, we're going to be, first of all, matching everything. And so in order to match everything, use that right there, and we say we want A to Z, right? So we're going to match all uppercase A to Z. We're matching all lowercase 0 to 9. Oops, 0 to 9. We're matching all numbers, and then because it could be a decimal, we'll put the dot there, and because there could be spaces in there, create a space, right? So these are the things that would be permissible for you to have inside of that area here. When you pass in a value, when we type in the value, whatever we type in after say can be, asked to match this criteria that we've specified here, right? That's really the point of it. And then now that we have our regex fully built out, we basically just need to return that. And we're all set. So we've got our attributes set up, the thing that's actually going to sit here, got it fully working. Now we need to work on how we're going to find these attributes, identify the methods that are associated with these attributes, and then we also then need to focus on, well, how are we going to invoke them, right? How do we pass the values that are coming from this string array args that have come into the program? How do we pass into this thing, right? So to do that, let's create another type inside of our Pigeon framework, right? And this will also be a class. This time, let me just call it command line. Okay. This will also be public. All right. So in here, the first thing we ultimately need to do is we need to be able to scan the environment that we have. We need some kind of initialization, and we need to be able to scan it. So let's go ahead and let's create a right. And what are we going to be scanning? Well, we ultimately have to scan the assembly that we are running in, right? Because we need to scan the calling assembly, right? Because this is going to be by itself. It's going to be called from here somewhere. Call, right? So we're going to call it from here. So when we call it from here, it's going to go into this command line, which is another assembly. So we need to be able to get that calling assembly. So we know that scan is absolutely going to have an assembly in it. And I don't have that. So let me go ahead and let's add system.reflection. And then we also know that you need some kind of entry point. We don't want to expose scan itself, right? So we'll probably want to have some kind of entry point for it. So we create initialize. Looks like something is failing here, right? This is an internal implementation. External customers do not need to know what's going on here. And then in here, I would then do assembly that get calling assembly, right? So that's going to actually pass the calling assembly in here, right? Okay. And so over here now, I can actually call command line that initialize, right? So that's going to start the process. And this is something you're going to have to call first with this pattern. With other patterns, right, there might be other approaches, but in this case, for this particular pattern, you would have to make this call first, right, where it's going to find out everything that it can about, the caller, find out where all your attributes are, inspect them, and then build a model that will then allow you to execute against it. So let's go back here now and let's fill this out a bit, right? So now that we're scanning, what are we actually going to scan, right? So there's two things we need to scan. We don't just need to scan the calling assembly. We also need to scan any assemblies that reference that calling assembly, because they might be there as well, right? So if we just did the calling assembly, then it would just check test harness. But if I had a class library that was a library of these things, it wouldn't check that. So we need to make sure it does that. So it seems like we're going to have to break this out into two parts, right? So what I'm going to do is I'm going to create something else, which essentially is going to do the same thing. Because first of all, this is void. Actually, since this is never going to be called, why don't we put it in here? So we'll make it an internal method, right? I mean, nobody else is calling it. It's only being used by scan. So the first thing we do is we obviously will scan what's already been created, what was already passed to us. We understand that. But then we then need to get all the reference assemblies, right? And this returns assembly names, not the actual assemblies themselves. So we'd have to load the assemblies after we get the names. So this here. All right, so what are we doing here? So I've basically just gotten the reference assembly names, right? So get reference assemblies, as you can see, returns an array of assembly names. So we're getting those assembly names. And then we need to load them. So my spelling is actually quite awful. Here we go, and I don't need that. Okay, so now that we've loaded that reference assembly, we can then do the same thing again, and then we basically scan it to load all types, right? So why aren't we returning anything? Because ultimately, what I want to do is I want to have this as a global variable up here. So I'm going to have a global variable of the command. What did I call it? Console. Okay, of the console command attribute. So okay. So the purpose of this right here, which I do need to make static, is that it's going to hold any of those command attributes that we found. So anytime we find one, we're going to add it to those attributes, right? So how do we find them? Well, we're going to have to do a big loop through everything, search it, and pull it back. Now, there's very efficient ways to do this, but this is a tutorial, so we're gonna keep it as explicit and almost like imperative as possible. So the first thing we need to do is we need to get all the types. And the types we want are the defined types, right? That should be types that you created in that specific assembly. So you don't end up with all these bloated types that we don't care about. Because again, you would have had to have created this, or the developer would have had to have created the things that we're looking at. That's all we're interested in, right? So we loop through that. And I think I'm actually going to rename this to, these are the defined assembly types, right? And then from those types, we now want to get the methods, right? So okay, so this guy, defined assembly type, and then we just want to get the methods. Okay, so this is now giving us all the methods for each of those individual types, right? And now we're going to get into some of the magic in here, right? So we're going to look through each. Okay, so what are the criteria that we discussed, right? To simplify things, because we're not dealing with instances or anything like that, we want to make sure that that any one of our variable, any one of the methods that you use have to have a signature of being static, and they have to return a bool, because we need the bool in order to control the REPL loop, so that you can actually control the REPL loop from within one of these methods. So what that means here is that let's go ahead and let's check for it. So if the type method that is static, right? And the type method return type is equal to a bool, then we know, that it's valid, right? We know that it's a method that we care about. We're going to ignore every other kind of method. Now, could this have been done up here, right? Where we do get methods? Absolutely. You could actually change this, right? We can do get methods dot where, and then you can pass this whole thing in there, right? And then, and then just get the list, and that would kind of give you the list that you are that you're looking for. I mean, it's the same as we say in as we used to say in Nigeria, it's the same 10 and 10 pence. I'm sure they say that in England as well. Okay, but back to the story. So now that we know the method that we're looking for, let's now go ahead and let's find the custom attributes that are declared on that method, right? And we know that for now we've set it up to only be one, right? So call it okay, so type method, get custom attribute, and the attribute we're obviously interested is in the console command attribute, and that's it, right? And now let's just check to make sure that that's not null, right? So perfect. So far we've gone through, we've started the scanning process, we found the assembly, we first check the assembly that's passed into it, we make sure it's the calling assembly, then we check all the reference assemblies, and for each reference assembly, we're going to call this internal method called scan types. Within that method of scan types, we basically find all the defined types. Those are the types that were created within that assembly. And look at the IntelliSense, the collection of types defined in this assembly, right? And then inside of there, we go through, we find all the methods for all those types. And for each method, we check to see if we're looking at a static method with a proper return type. If we're dealing with a static method with a return type of bool, we check to see, we basically get the custom attributes associated with it, which in a way is a way of checking to see if that custom attribute is defined on it, right? Now, if that custom attribute is defined on it, what do we need to do now? It's time to go to work. We need to essentially take that custom attribute. We need to pull some information out of it and populate these values, right? So what value do we already have? Right now, we do have the target method, right? So we can go in here and we can say console attribute that target method equals, right? The type method, right? So we fill that one out, right? Well, the next thing we need to fill out is we need to fill out this tokens thing, right? Because without filling out this tokens property, this pattern regex is not going to work. So let's go ahead and let's fill that out. How do we do that? Well, we're going to have to do a little bit of like funky parsing here. So let's go ahead and do for each character. And did I spell that right? Yeah. And so that's that pattern thing that we talked about. What are we doing? We're going through this pattern. So we're going through this right here. We're going to go through this, right, character by character, SAY. And what are we looking to do? We're going to go through this whole thing until we get to this character. When we get to this character, that's when we know that we've hit a placeholder. If we don't get to this character, then who cares, right? It doesn't matter. We just treat it as a, as a verbatim string and just compare the input that you've passed in directly to whatever is there. If we encounter this, then we know that there's more than one token, and then we have to build up this sort of this list of tokens. So let's go back in and let's try to get that. So in order to do that, we are going to need a queue, right? Character queue. So what does the word queue do? Well, we just keep populating the word queue. And then once we hit that, once we hit some kind of delimiter or boundary, we convert it into a string and we store it as a token, right? In one of those token lists, right? So we're gonna do a switch here. Okay. And one case, so that's the first case we talked about. And then we also need the other one, the closing. And then finally, we need default. Right, so that's all that counts for this. Okay, so I'm just doing this to encase these so that, so that there's not much name, so we don't have any name collision. So if it's not this or it's not that, then we're just going to add it to the word queue. Okay. If it is this, then we know it should have populated a little bit. So get the word. We create a new string from it. Then we clear thing because we're resetting and starting from scratch. And then for this particular attribute, basically add a new token or new text span, which is the token. And then here, the text is going to be the word that we just created. We'll see. There we go. And then over here, we essentially need to do the same thing. The difference is that over here, this is a placeholder, right? Over here. Right, so by default, I didn't put is placeholder false here because by default, the placeholder will be false. But in this case, so when you start here, by the time I hit this, it's just gone through and created words. Everything I've done up to the point that I hit this, so everything I've done S, A, Y, everything here. This is not a placeholder, obviously. Once you hit this, it creates this and stops, and that becomes the first token. Then you start reading through this, and by the time you hit this, then the text you have is the entire something, which of course is a placeholder. So that's why once you hit this, we put in the, we identify it as a placeholder, and we are basically done. There's one more case we have to worry about, and that's in the scenario where, as stated, there is no token. So when there is no token, this whole loop is gonna go through, right? And when there's no token, this whole thing is gonna go through, and by the time it's done, nothing would have been added to, to our as our tokens. And by default, there should be at least one token, right? So we're gonna first of all check to see if there is something in the work queue, right? And if there's something in the word queue, then we will basically do the same thing we did before. This should probably be its own function as well, but let's not do that right now. Okay. And I'm going to call this last word. And then I'm going to store that there, right? And that's that. And actually, you know what? Why don't we go ahead and let's move this down here because it flows better. So and then now that that's all done and we have our method, the final step is that we then take this attribute and we store it in our discovered commands, right? So, okay. So now that we have that all set, the only thing we have to do is we need to see about when something is not found. We need to basically identify that not found attribute that we created, command not found, right? So, and of course, once that command is set, and you have to come up with, your own rules of how you want to do it. But for the purpose of this exercise, we're only going to set it once, and we're going to set it the first time we encounter it. So we check to see if this is there. Obviously, if it's a console command attribute, then that's what's going to be used, right? If it's not a console command attribute, then we will then check to see if it is a not found attribute, right? But before doing that, let's add the not found here. So okay, over here, I will now say if not found is equal to null. Okay, so what I'm saying is that, hey, if I haven't already set the not found attribute or the not found value, the not found property, if it's not already set for the scope of this scan, then let's go in and let's see if this method has it, right? So we'll go here, I'll change that to not found. And of course, I'm gonna change that to command not found. You know, I don't like this name console command. Okay, I'm not going to change it right now. I'm not going to be neurotic. Okay. And so if found attribute is not equal to null, so that means that that attribute exists on there. Then I will set it. Bob's your uncle. That's it. So at this point, let's do a build and see if we got all the I's dotted and the T's crossed. Okay, so at this point, we should be able to actually run this, right? And I'm actually going to I'm going to put a breakpoint here so we can see what it creates. So let's run this now. All right. So it's now gone through and done everything. Not found as null. Oh, sorry. Discovered commands is null. So let's actually go in here and let's see what's happening. Make sure we got everything properly configured. All right. So we've now gone in and we're looking at the test harness, right? That's the calling assembly, right? And let's get the methods. So there's 7 methods in test harness, right? Oh, sorry. Let's see which type we're looking at. Actually, I'm going to go in here. Before continuing, don't forget to do that. You can change the binding flags at some point in the future. All right, there we go. Now we're seeing these guys. So what's happening is that when we get the methods, let's stop this. When I get the methods here, the binding flags that. So I want the ones that are non-public or public, right? And we probably need to do this for types as well, but we won't do it right now. Then I should be able to go back here because honestly, you don't want to make this, you don't want these to be public or you don't want it to matter ultimately. It doesn't seem to be picking it up. So for now, there we go. So it's all in there. They're public, they're static, here's not found, all done. So we're in a good place. So we've loaded everything. We have all our command attributes and our command attributes. Sorry, I'm sorry. Yeah, we have all of them. They all have the appropriate tokens that need to be had. All right, this one is called. All right, so seem to be done. And we pull that back and we see 4. We got 4 here. And so the reason for that is that over here, we're still using the inspected assembly as opposed to using the referenced assembly. So that should go there. Now, when I run this bad boy, I should see that it's discovered one and it has a knockdown. So that's exactly the state that we want to be in at this point, right? We're basically, let me get out of here. So we're basically done. The environment is initialized, it's ready to go. We have all our command arguments, we have everything that we need, and we can actually start operating on these. And actually, one thing that I did want to show is I want to show what the, what the patterns themselves look like, because you would have that here as well. So let's just take this guy. So here's the regex. So you see it's say, and then that's the other part, right? If we say something, it's represented as this regex here, right? So what we then need to do now is when you pass in your value, we're going to evaluate it against that regex. And if it's a match, then we call the function. So let's take it to the next step. So now that we're done with that, go ahead and create a bool, because again, we're going to be, this is for the execution. So we're going to be executing against, we're going to be executing that function. And when we execute that function, it's going to return, right? So we'll just call this run. Or maybe interpret. Is interpret better? Or execute? Maybe execute. We'll use execute. And of course, because it's the string args thing, we're going to do string args, right? And for now, we'll return false. Okay. So basically, you're going to be taking, after you initialize, you can then call command line dot execute, and then you just patch in args like that. And that's all you need to do, right? But of course, what we're getting when we call args is we're getting a list of an array, right? And somehow we have to, for us to be able to evaluate it using those regular expressions, we have to be able to convert it into an actual string. So let's go ahead and let's add a function here, right, to do that. Okay. And we're gonna pull out the old string builder again. And then in here, I just want to do a little bit of append. And then in here, I'm going to be appending a parameter, and we're just going to have a space there, right? And then this should obviously not be that. It's next to a string. And then we will then return. There you go. So this is essentially going to convert these args into a string, right? We can now do okay. And now that we've done that, we can then execute that line item. But I don't want to execute it in here, right? I want to take all the code because, again, we're talking about the fact that it's not just going to be an args array. It could also be, used within a REPL loop. So we do also have to account for just a normal string injection. That's another overload. So we'll add that overload. And then in here, we will now, that's the actual command line. And of course, we'll return false as well. Because we've done that over here, what we can then do is we can then do okay. And honestly, I wonder if there's a need for the args array over here. That's really needed. I don't really think it is needed. I should be able to do this. That's needed there, but this is always going to be a one shot, right? So in here, what do we need to do? Well, we need to loop through all the discovered commands, and we need to run a regex against it. We're gonna need to take our command line and regex our command line versus the pattern from that discovered command. If it's a match, then we'll invoke and execute. If it's not a match, then we'll let it go and we'll return that. We'll invoke and execute that not found, right? So let's get started. So first of all, we need something to represent the parameters for the method. Right. So usually in reflection, the parameters when you're auto invoking a function or method, I should say, you actually pass the parameters as an array. This is the parameters object where, again, we talked about the fact that if you have a placeholder, that placeholder is going to get injected into the method. So if we go back over here, we've got to be able to pass, when we invoke say something, we have to be able to pass a value into something. So we need to start preparing for that, right? So that's what that's there for. Right, and then what I'm going to do is, before continuing, I'm actually going to trim the command line. And as this is going to be lowercase, I'm going to make it lowercase. Okay. And then and so this is going to represent the target command that we're going to set and we're going to use to actually return things in the end, right? And then okay, so we're going to loop through that. We're not going to worry about that right now, right? And then once we're done, that's going to be set somewhere in that loop. Once that's done, we're going to test to see if it's still null, right? And if it is null, then we will just return an execution of not found. Actually, now that I think about it, I think what I'm going to do here is I'm not even going to pass that around, this command not found, because I would have to create a type right? I'm over here setting this to not found, but I know right now that this method, right, is the not found method. So what I'm going to do is I'm going to change this to a method info, right? And then over here, I'm going to just put that there, right? So the method info is used. And then over here, I'm just going to invoke that, passing a null for the type, and there are no parameters. So this has to be a parameterless guy. And I think here, this is a, so yeah, that kind of went away. I mean, nothing really changed. This basically is it. So what's gonna happen here is that if I don't find, this is my chance to find, to find a match based on this command line input that I passed. If I don't find a match and it's come out, then target is gonna remain null. I'm gonna set target in here, right? And then let's say that, and so this returns. So the assumption is that if I get to here, then it means that this has been set to, to a value. That means that I can just, get that value. So that means I'm going to take this and then I'm going to invoke it. And of course, the type is null, but the parameter will be method input parameters. There we go. And this has to be converted to a Boolean. There we go. Okay. So this is going to invoke the method that gets set in here, and we're going to be passing in the parameters that will also be set in here, right? So everything is going down in the for each. All right, so let's get in here. And let's see what we have to do. So let's get rid of this. So what we have to do, well, the first thing we have to do is, once again, if there's just one token, it means that there's just, it means that there's no placeholders, there's no pattern, or there's nothing like that. It's just a thing. And if there's no placeholders, then it's just a verbatim string, and we're going to treat it as a verbatim string. So let's go ahead and let's get rid of that scenario first of all, right? So that's wrong. You don't know me, Visual Studio. Right, so here we go. So in this scenario, nothing has changed. So I'm going to convert the target command into the discover command, right? And that's it. So that was a pass one value, right? The value gets passed in there. So the only thing we need to do now is we obviously need to do that string comparison, right? So we already trimmed and to lowered everything. So now I should be able to do check the discover command pattern and compare it to the command line, right? So this in and of itself will cover the scenario where one item has been created, where there's no pattern. You can build this, build this. And if I go here, let's go ahead and let's add something else. Let's say hello. Okay, so what I've done here is I've just added another one called say hello, which returns true, but really honestly doesn't matter in this case. And now what I'm going to do is I'm going to go in here, back to the properties, and let's say, what's that called? Say hello, something like that. Let's check this real quick. Oh, hello there. Okay. So we should be able to run this. I'm actually gonna do it so I can stop it. Let's go ahead and run this. And we have an error. Over here, we gotta get rid of this guy. Whoa. And might want to put a breakpoint here on that. And there you have it. As you can see, I passed in this argument, right? These args have been passed in. Boy, I should have probably done a breakpoint there. Let me close that again. Right. So my arguments are hello and there. As you can see, here's the complexity. It's showing up as two arguments because there's a space. And then when I call execute, it actually calls the hello there and then executes that. So if I remove all this, just run it, you should see calling hello there command. Perfect. Okay, so we're on the right track moving forward. Let's now continue back here. Now we've got the basics working, and let's work on what happens when you have more than one token, meaning that there is some pattern, right? So go here. So now what we need to do is just need to do a regex match based on, based on the item. So command line is the input string, and the pattern would then be for that discovered command. The pattern, as you see, Visual Studio's amazing IntelliSense basically do it for me, where all I have to do is hit tab. And we want to make sure that this is single line. I mean, you could modify this for multi-line in the future if you want. So now that we have that, we basically match on success. And since we know it succeeded, let's go ahead and let's set that target command. Let's get that out of the way first of all. And so that's going to make it call that method. So we now know it's going to call whatever is matched. But now that we know it's going to call whatever is matched, we need to move on to the next one, the next phase of it, which is how do we pass the parameters in? So first of all, let's initialize the parameters. So method input parameters. And we're gonna get the number. We're gonna create the number of parameters based on the number of parameters associated with that method, which we have. because we have the method already. The target method that get parameters, right? Right, so this is going to create the parameters that are just, just the right number for this thing, right? So now what we need to do as a final step is that we need to set up the parameters so that they match the the order that they are in the method. We basically have to match them one to the other. The good thing about it is that these parameters, they obviously they have a name, right? So we can search based on the name, right? So we, if there's a something here, I should be able to find a something there, and I should be able to index it based on that, and yada yada yada, right? So for example, if I did a something, else, and then here I would have to have a something else string, right? Like that. And my system, or this, what we're building, should be able to indicate, it's going to first find something, then it's going to find something else, and on and on and on, right? So let's loop through everything. First of all, let's just find all the placeholder tokens, right? That's step one. Now let's get the text for that placeholder token, right? So what are we doing here? What is this groups thing here? Well, remember over here when we're looking at the text, there we go, the text span. I'm actually going to move this out. There we go. So we have that as well. So remember over here, sorry, where we're doing this, we first of all started with just doing this like that. So what I want to do now is I want to set it up so that it's doing some kind of grouping into a value, right? And the value I wanted to group into is the token text, right? So these are all regex commands, so you can look this up yourself. And I want to right, so what it's going to do is when it does this match that I have here, right, it's going to put it into a group named this, right? So when it matches it, it's going to put it into a group named that. So going back to the example here, when I match something, when it matches this whole thing, it's going to group it into a group called something. And for this one, it's going to group it into a group called something else, right? So what I'm doing here is that after I find all the placeholders, right? And then for each placeholder, I know that the text for that placeholder is going to be a group. So I'm going to that group, finding the text, and pulling out the value of that text. So whatever is supposed to be, so I'm gonna type something like this, say hello, John, right? So based on that, something is going to have John and hello. And something else would have John, right? So that's what's going on here. So there's a distinction between the name of the parameter or the placeholder and the value that the placeholder is passed based on the input string that you pass in, right? Let's make this a little bit more command liney. Right? Okay, so I'm going to say something about something else, right? Like that. So as you'll notice, it's still the same two things. So when I pass it in, I'm going to have to, pass and say what? Hello about. Actually, I'm going to change this to 2. I'm going to change this to someone. Change this to someone as well. So it makes more sense. So say what hello to John, right? That's how it's going to come in. That's going to say hello. That's going to say John. That should say someone, right? Like that. Something, someone. All right. So let's go back here. So now we have the placeholder text. So this might be something, and this would be the actual value. So hello, right? So now what I need to do is I need to find what parameter in this method has the name of this placeholder text. I mean, this could be done in any order, honestly. All right, there we go. So I now have the text that's going to be passed in, and I have the parameter that I'm passing it into, right? The two key things that I need. And because I now have the array, and I know that the array is the full length of it, and I have a parameter, and the parameter has an actual position to it, I can basically, once I find it, I can actually set the value, in the array to the value of the placeholder text, okay? And so we could just do it plainly and just say we're going to use just string. But to make it a little bit extra, I'm actually going to add one for every single, the various types that we might be dealing with: string, bool, float, things of that nature. And then we could take it from there. Okay, so we've created all those parameter types I discussed, and I'll just walk quickly through it. For brevity, I just thought it'd be easier to just quickly do it. So basically, now that we have our target parameter, we just go in and we check what type it is. Based on the type, we really only use that to determine what value we place into that slot of the method input parameters array. It's the one we set up here and the one we defined the full length of based on the actual target method's parameter count. So once we have that set up, then we go in here and we just populate it. you find the parameter in the method and you take that position, and in this array, you specify the position and you specify the placeholder text, not the actual name of it, the actual final text, place it there. Now, in scenarios where it's a bool, then you parse it by the bool or float or double or decimal or int or quid or whatever. The final thing that we then do is, in the last case, meaning that it's none of these things. It's not a string, it's not a bool, it's not a flu, it's not a double, right? Any of the things that we're sanctioning for it to be, we're just gonna treat it like it, like it's like we didn't find anything, right? We're gonna treat any scenario that's outside of the ordinary as though we haven't found anything, and we're just gonna return like nothing was found. And ultimately, because nothing is found, we'll actually break out of this for each loop. Because if anything is not there, then it's like, if anything is all out of whack, then it's like it's not there. Then the only other thing we need to do is for scenarios where there's some kind of error, like an input formatting error. It's the same thing. We're really ultimately just going to do that, but we probably want to specify some kind of error message. So an error. Let's see if I can write something cool here. Let me say. Okay. And maybe, what would be cool? Let's change the color. And then once we're done, we obviously need to reset that color. There we go. So this will show up as an error in the command line. But other than that, should be good. Let's build this. Right, so that works. And we are good to go. So what we now need to do is we're going to take this whole thing and let's go ahead and let's put these properties, pages. And change that to that. And over here, just put that. Let's run this. All right, so now we're getting a no command found. Let's see if we can fix that issue. So it seems like in the midst of doing everything, I entered pattern over here instead of pattern, right? That's really the only difference, right? So let's try that again. And as you can see, you're now getting, you said hello to John, right? Which is what we're expecting. We can run this again, close some of these guys. And maybe put a breakpoint here, run that. And as you can see, the breakpoint is being hit and something now says hello, which is what we passed in, and someone now says John, right? So that's the basic command line, and this gives you a one-time call experience. But let's take it a little step further and let's actually build out a REPL loop just to end this, so we can kind of play around with adding multiple commands at a time. So you're still going to need execute, but as you recall, so you're still going to need initialize, but as you recall, we have two forms of execute. We have the execute that takes the args directly from the command line. So I'm not going to need that anymore. So let's go ahead and let's remove that, but we don't want to trigger that. And then not that you would, and then you have the normal execute that just takes a string, right? So let's go ahead and let's create something like this so you can kind of see how one might do that in REPL form. That's our basic prompt, right? Okay, so now we're reading the line, and then I'm gonna call it command line anyways. We're passing that in, execute, that returns a string, a bool. Okay, and then we just check that. And we break there, and that's it. So it's a pretty simple REPL loop. And maybe up here, before I do that, I put okay. So we should be all set right now. So let's run that so we can see that variability at work. So first command here, let's just copy it. Okay, so that works. So I can change that. Right? And I think we can add spaces. Right, so either will be there. Right? And then what's the other one? We can still type hello there. And that will call hello there, right? So we essentially have command line ready. All we have to do as we want to, if we want to extend it, is add more things, right? So I can stop this. Let's say, I don't know, want to do another thing here. We can add another one. It's just a matter of adding a new function and saying what you want it to say. So maybe I'll change it to do. Put a colon for this one. Right, so I'm not adding a new one. And we can test out this whole idea of variables. I'm sorry, of different types. So okay, so we can do application of number. So now we have this do command. And again, I'm just playing around here, but we do Actually, you know what? Let's do something here. There we go. So it's just gonna loop through all that a whole bunch of times. So let's do. I want to say a little there, and that's not gonna work because, oh, it is gonna work. Oops. So again, do. And time equals 10. There you go. Calling to 1, calling to 2, calling to 3. So I just added a new command. I haven't bloated anything. It's all working perfectly. And then for a final test, let's explore imagining having an outside library being added in here. Let's add a new outside library. Okay. So we create this here, and same whole. I'll actually move this do command, right? And I'll just put it here. Okay. And of course, I need to add a dependency on the Pigeon framework. And use that. So that's all the same now. So do is now outside of this library. And we'll now check to see if this exists. No, it does not. Pigeon framework. So this gives a good chance to show you this not found. So I'm not going to run this. Move this up. Same REPL. And oops. It died on me there. So let's do that again. Do. And oh, oopsie. Typed the wrong thing. Do W. Okay. So we're running this now, and this should fail. And of course, when it fails, what's going to happen? It's going to come in here, and notice this is false. So the application is actually going to close, right? So let's run that. See, it says not found, right? So how do we add that? Well, we have to basically just go here and add a reference to the test lib, and then just run that again. Now when we run this, so as you see, when we run this, now that we move this guy over out of the assembly, and we actually run it, the reference assembly, which it should be showing up here, is not showing up, and that's the issue. So what's a fast way to resolve that? Well, an easy way to do that is to actually explicitly load a type into the environment. And you can do that by simply calling one of the types that are a part of it. So, can kind of just have a blind init method here, and I can do class 1.init, right? And then once I do that, I should be fully set. If I go here, you can now see that that's now showing up. So the reference assembly piece is working, right? Everything is loading. Now when I do that pigeon, coming in perfectly fine. So that's all, folks. In this video, you learned some C# concepts, some of the cool new things going on in C# 11, where it was put in, but most importantly, we showed you how to build a console interpreter application using this Pigeon framework. If you have any questions and you want some assistance, you can go to the NuGet. Everything you see here is going to get published to NuGet. Pull it down yourself. If you have any questions, you can reach out to me on all the various interwebs. And once again, the channel is brought to you by your likes and subscribes. So please like and subscribe if you like our content. And as always, have a blessed day and happy coding.